All right, guys, I wanted to make another video about factoring difference of squares. Okay, now this is a special type of factoring that we get to do, and I want to show you what it looks like. So first of all, I want to show you something, how we can have something that's factored, and I want to show you that you can have numbers work out such that when you get to the end, you only have two terms, the x squared and a minus 49. Okay, and this is kind of the idea behind difference of squares. So I'm going to start by just multiplying this out, x times 7, so that'll give me x squared plus 7x, and then negative 7 times x and negative 7 times positive 7, that'll give me negative 7x minus 49. And then notice what happens here when we go combine like terms. What happens when we do 7x minus 7x? Well, that actually becomes 0. Negative 7x plus 7x is 0. So all I have left here is these basically make 0. And all I have left is x squared minus 49. So what we can say is what we started with is equal to x squared. I can now say this, x squared minus 49 is equal to what I started with, x minus 7 and x plus 7. Now notice the relationship between what we put in the parentheses and what we have right here, that 49. Pause the video for a moment and try and figure out what is the relationship between 49 and 7. Okay, pause the video and see if you can figure that out. All right, so now if you were to pause the video and kind of figure out that relationship, the relationship between 49 and 7 is the square root of 49. And when they say difference of squares, they're talking about perfect squares. So just a quick reminder on perfect squares. Perfect squares are numbers that come as a result of multiplying two numbers, two of the same number together. So like 1 times 1, or 1 squared, is equal to 1. 2 times 2 is equal to 2 squared, or 4. These numbers being perfect squares. If you follow this pattern, you get 3 squared is 9. There's another perfect square. You get 4 squared, that's 16. There's another perfect square. And so on down. For a list, the first 10 perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. Okay. Knowing the relationship between this number and how it gets factored will actually make this really fast. Okay. I'm going to show you a couple different examples here on the next page. Now notice, we have x squared minus, and the reason they call it difference is because you are subtracting right here. This is a subtraction problem, all right? And so we have x squared minus 64. And if you look back here on our perfect squares list, 64 does in fact end up on my list. And so if you look at the relationship between those two things, the difference of squares, what's the square root of 64? Well, that number is going to go here and here. And then if you look back at our relationship, one had a minus and one had a plus. And what that does is that allows us to cancel out these two middle terms. And therefore, all we have is x squared minus 49. So one of these 8's has to be a negative, and one of these 8's has to be a positive. Okay? And that's kind of the really quick shortcut way of doing something called difference of squares. Now, the way you know that it's difference of squares is this second number. That second number right there is a perfect square. And so you kind of have to commit some things to memory, or at least be able to pick out and notice that these 10 numbers are perfect squares. So again, if we go back to our example here and we go like this, we're going to put an x here and an x here. I see a perfect square there, 100. So what's its square root? Whatever its square root is will go here and here. And if you know the square root of 100, it's going to be 10 and 10. And one has to be negative and one has to be positive. And that is factored. Okay. I do want to show you a couple of other problems here. Let me do two more here. Okay, let's go x squared minus 16 and x squared minus 49. Okay. Now, in my previous video about factoring quadratics intro, we said this. What two numbers multiply to negative 16, because that's my constant, the one without a variable, and since there's no middle term, we're going to think what adds up to 0. This is a different way of doing the exact same thing of what I just talked about on the last three examples. Okay, so what multiplies to 16 and adds up to 0? Because there's no middle term like there is here. There's no middle term there. It's just x squared and a number. X squared and a number. And so really we can say, okay, this is really, right in there is a 0x. So again, we're trying to figure out what multiplies to negative 16, and those same two numbers have to add up to 0. And if you notice, it's going to be 4 and negative 4. And so then we just take these two numbers and we put them inside our parentheses, x minus 4, x plus 4, and then that would be factored. Okay. Same thing over here. What multiplies to negative 49, and again, since there's no middle term, we're going to think what adds up to 0. So pause the video and see if you can answer that question, either using the square root method or using this little chart here to organize your information. So what multiplies to negative 49 adds up to 0, or do the whole square root method. Pause the video and try that out. All right, so you should have gotten x minus 7 and x plus 7 for the two numbers that multiply to negative 49 and add up to 0. That's a quick little intro to difference of squares in factoring.